In this video, we'll see about the next analysis of truss, that is method of section. In our last video, we had seen about method of joints. Now in this video, we'll see about the method of section. The difference between method of joints and sections I'll define you now. See here, consider a truss like this. When you're analyzing using method of joints, you will take each joint and you will analyze separately to find the force of the members. Like at each force, you're going to find the force of the member at each points. So using the joints, you're going to calculate the member forces. This is the method of joints. But in some cases, we have to find the method of section, in which case we have to adopt like, consider this is the member truss. In some cases they may ask you only to find the force at the members in this member, in this member, or in this member. So we have now only three member forces to find. If you are using method of joints in this sum, we have to take each joints and we have to analyze it. But what we can use instead, we can use the method of sections. So using the method of section, we can divide the truss into different parts and we can find the member forces. So to find this, you can take a section, like crossing the section using the maximum number of forces to be find. If I want to cut the section, I should not cut it here because my maximum forces is not lying in this member. So where I have to cut? I have to cut in the number of forces. So I'm taking this as a section so that when analysis I can get this force as well as this force. So the section separation, you have to be very careful and you have to separate it. This can be easily understood when you're doing the problem. Listen to the problem now. Determine the forces in the members BC, BG, EG and GD. So that in the question they had asked particularly to find the member forces of EG, BG, BG, EG, GD and BC. So that four forces we need to find in the 9-member section. As usual, we have to find, we don't want to find whether it is statically determinate or indeterminate. We can go directly to find your conversion and you can go for your reaction calculations. Now we are converting this into a simple problem. Since they had given a car is moving on 30 kilonewton per meter, that means it is your UDL. To convert your UDL into point load, we already know that we have to separate that at two point of junction at 60 and 60 kilonewton each. And this 20 kilonewton is a reactional force or force of your member that is divided into two, that is vertical and horizontal. After calculating the angle, the angle can be calculated using the formula opposite by adjacent. So after finding that, you will get a theta value that will be equal to 53.13 degree. So when you do that, you will have the truss member like this, including your reactions. Consider here, this is your reactions. Here it is your simply supported, so you will have one at this and the other one facing like this. Next one will have only one reaction. But in this case, we have a force which is also going to act in a horizontal way. That means this is not going to act in this direction. It will just change the position to the negative. This is a normal condition actually, because already there is one force which is pulling in that direction, so that it is not going to move in this direction, so it will automatically change its position to the negative direction. Now we are going to convert this into a different sections. Okay, before that I need to find what is my reactional value. For that I am going to take summation of horizontal forces is equal to 0. How many horizontal forces are there? RCX and 20 cos 53.13. So RCX will be equal to 20 cos 53.13. Why? Because RCX is in negative direction. See here, Okay, take this condition first. This RCX you mentioned like this because there is a force of 20 cos 53.13 acting in a right direction. So when you are doing that, your horizontal forces will be equal to RCX, you will get a value like 12 kilonewton. And when you do summation of vertical forces, you will get an equation RA plus RCY will be equal to 104. Then you go for the moment and find out the reactions first, because finding the reaction is the first step. Always in our previous method also, we just analyzed using our normal condition. We have to find first the reaction, then only you have to calculate the forces in the sections. So first step is to find the reaction. If you are not able to find the reaction using only two equilibrium condition, take the moment equation and find the all the reactions. So now we had found all the reactions RA, RCY and RCX. Now we have to divide the section into two parts, so it will be easy for you to analyze further. So this is your member and we have to find the forces and this members, right? This force we have to find, this force we have to find, and this force we have to find, and this is the force we have to find. So that we are dividing this member into two sections. So I'm cutting this so that my maximum coverage will be three members at a stretch. So this is my first section, so I'll analyze this whole portion to find the three member forces. Then I am going to take the this point, that is sectional 2, and I'm going to analyze this part so that I'll get this force. So this is the method of section. Consider the first section now. This is your first section which has a point, which has this a point and this point, this point, this and this and this and this. This is your first sectional part with 38 kilonewton. That is what I had mentioned over here. See, in this diagram, this is the representation, that is 60 kilonewton is going to act from top to bottom at that joint. 38 kilonewton is the reactional force, and FEG, FBG, FBC with an angle of 36.87 degree. Same usual step, you have to apply the equilibrium condition. Summation of H is equal to 0. In that you will get one equation. Then you do it for summation of vertical forces is equal to 0. When you do that, you got a value of F of BG which is equal to 36.67 kilonewton. Since it is positive, what is that means? It is a tension member. So after getting that, just put that equation, put the value of F of BG in the first equation and get another one equation. Now you have to find three forces. Already you had substituted two equilibrium condition, but one more force you have to find. For that I am taking the moment equilibrium condition also. When you are finding moment, you will get the other force, that is F of EG is equal to minus 50.667 kilonewton. That means it is a compression zone. Substitute this in the equation to get F of BC value, that is 21.33 kilonewton. Since it is a positive, it is a tension zone. See, I had taken only the first part of the truss and I had analyzed using three equilibrium condition, so that I got three member forces, that is F of BG, F of EG and F of BC. According to the symbol, I am just mentioned that whether it is a compression or tension. Now what is the next step? We have to move to the next part of the truss. So that I am taking the next section, that is on this member. So see, this is what this one, 20 53.13, 20 cos 53, this one, this is one thing and this is another one thing. So this is your first section. So I had mentioned over here, so that 20, 20, FGD and FCD. Here the unknown are 2, FGD and FCD. Substitute that as the same method. Do it for summation of vertical forces. Why I am taking only vertical forces over here, not considering the horizontal forces? Because when you are considering horizontal, you will get directly your value for FCD. When you do vertically, you will get FGD value. That is what I had mentioned over here. When you do it, you will get a value for F of GD as compression. So you got four different types of members. See the question, they had asked you to find only four members forces, this one and this one. Already you had found this three using the section 1 and 1. I'm going to take only this point now. This is your second section. In that second section you got already the value for b to c. So three factors are known, only this factor is an unknown. So that only I am just substituting summation of V to find out the remaining force, that is F of GD, which is I got the value as minus 26.667 kilonewton, which is in compression. This is what the sum. You can tabulate it as per the method of joints. You can tabulate, write the serial number, write the members what they had asked, give the magnitude of the force and mention the nature of the force. This is the sum to do how to do the method of session in Truss analysis. Go through this sum. Please do care that take your note and do this problem by your hand, because you need to know how to solve this. Don't just see the video blankly and sit. You do the sum and do practice it regularly. So I'll give you some workout problems for your practice. Take this question and analyze it using your using method of sessions. I had asked you to find only four forces at four members, G, C, B, C, C, D and E, F. But the sum is very large. You can divide it into two sections and you can analyze it. For your easy purpose, I had divided the sessions. So try it on your own. I will just give you the answers in Google Classroom. So try to do this sum also. It is using method of joints. So up to this module got over. So do take care and study your beam analysis as well as your truss analysis, but do take concentrate more on your beam analysis, then go for your truss analysis. Okay, thank you all.